Hello everyone and welcome. In the last lesson, we discussed relative and absolute cell references. In this lesson, we will discuss some advanced applications of relative and absolute cell references. So far, we have been writing absolute cell references of the type $D, $5, where we have the dollar sign before D as well as 5. Now it's possible to put the dollar sign only before D or only before 5. Let's see how that works. If I write a formula as equal to $D5, I have fixed D but left 5 open for updation. When I copy this formula and paste it in some other cell, you can see that D has remained unchanged while 5 has changed to 10. Similarly, if I write a formula as equal to D$5, I have fixed the row number 5 but I have left the column number D open for updation. When I copy this formula and paste it in some other cell, you can see that D has changed to G while 5 has remained unchanged because we had fixed it with a dollar sign. Therefore, the basic concept is that the dollar sign allows you to prevent cell references from updating automatically. Now this concept has very interesting applications. Let's look at one such application. In this example, we have a loan of 2 million and we need to estimate the simple interest accrued on this loan at various loan durations and interest rates. Each cell in this table needs to be filled up with the proper accrued interest. For example, in this cell, you need to estimate the interest accrued on a loan of 2 million over a duration of 5 years at an interest rate of 10%. If we write formulae that do not use cell references, we would have to write a separate formula for each cell in this table. For example, the formula for the first cell would be equal to 2 million multiplied by 2 years multiplied by 8%. The second cell would be equal to 2 million multiplied by 3 years multiplied by 8%. And we would have to repeat this for each cell in this table. Now let's see how we can use cell references to write one formula and copy it to the entire table. In the first cell, I write a formula as equal to $D$2 multiplied by $E8 multiplied by F$7. So this multiplies 2 million with 2 years and 8% to estimate the accrued interest for the first cell. Now let's pause and look at this formula. I have put dollar signs before both D and 2 because for all cells in this table, the loan amount should come from cell D2. Therefore, I want both D and 2 to remain fixed. Here, I have put a dollar sign before E but no dollar sign before 8 because for all cells in this table, the loan duration should come from column E. Therefore, I want E to remain fixed. And finally, here there is a dollar sign before 7 and no dollar sign before F because for all the cells in this table, the interest rate should come from row 7. Therefore, I want 7 to remain fixed. Now, let's copy this formula and paste it in some other cell. And let's observe both of these formulas very closely. You can see that D2 remains unchanged, so loan amount is coming from the cell D2 for both these formulas. Next, E8 has become E11, so loan duration is coming from column E and the appropriate row for both these formulas. And finally, F7 has become H7, so interest rate is coming from row 7 and the appropriate column for both these formulas. So you can see that combining absolute and relative cell references has made this formula so flexible that it works for every cell in this table. Now I can just copy the formula and paste it in all the cells to calculate the accrued interest for each cell in this table. At this point, I believe you can appreciate the utility of cell references while writing Excel formulas. This topic is very interesting, but it is also a little tricky. So I suggest that you go through the exercises provided as part of this lesson. Hope you enjoyed this video, and as always, Thanks for watching.